Okay, so linear algebra, lesson 1. First, I want to introduce some concept about linear equations. There are two kinds of linear equation that you will see. One is homogeneous, the other one is
Non-homogeneous.
okay. Can you tell me what's the difference between homogeneous and other non-homogeneous, as we discussed last class in calculus 1?
Yeah, it's the same concept as in calculus, I assume. So it's homogeneous, does not have a constant in
Okay,
equation.
so the constant term will be equal to 0.
Yes, zero. Non-homogeneous has a constant.
So the constant term is not equal to 0. Okay,
Yeah.
and okay, that's a good difference. And okay, if I ask you the difference between homogeneous and non-homogeneous linear equation in respect of to the number of solutions.
Okay. So as we discussed in calculus, in homogeneous equations, we have infinite solutions since we do not have a constant. For if we have two variables, we have to at least have two equations to find the variables. If we have less than equations as the number of variables, we cannot have a solution.
Okay, let me refine it perfectly. So in homogeneous equations, there are two possibilities. Either you have infinitely many solution, other one trivial solution.
Trivial.
Yeah.
Trivial.
So one trivial solution and the other one is an infinitely many solution. What does it mean? Okay, the homogeneous equation looks like ax plus by equal to 0. Okay,
Okay.
so it can have infinitely many solution. How? Infinitely many solution depends on the free variable. You will see with the example. I will show it to you. And there is a case that it will have always a trivial solution, that is 0. 0 will always satisfy this equation. If you put 0 comma 0, it will always satisfy the equation. So there is no possibility that it will doesn't have a solution.
Yeah, it has at least one.
One solution. So it has at least one solution. Yeah.
What's the exact meaning of trivial?
Trivial is means a mandatory. It's a sure shot. The trivial is a for sure shot. 0 is a solution.
Okay, one trivial
Yeah.
solution.
So at least one solution. Here you have three possibilities. First possibility is no solution.
Okay, yeah, this is the one.
Second possibility, you have like one particular solution like this. Then you have infinitely many solution.
Okay.
Because it is a non-homogeneous, so you will have a particular solution that we say as, I am writing as particular solution PS, and this is GS as general solution. So if you solve only the homogeneous part of the linear equation, you will get the general solution. Then you have one more case as one single solution. I will give you some examples that you will see. Okay, how it is happening, but in short I will give you some notes before jumping to the question. It's a tricks. So first of all, if you analyze on this part, okay, who give you infinite many solutions? Like for the infinite number of solution depends on the free variable, right? If we have a free variable,
Yeah.
then we will get infinite many solutions. So I'm writing it: if we have free variables, okay, to which row that you have put in the substitution, you have to take that r2 equals to 2 times of negative 2 times of r1 plus r2.
Okay. Yeah.
Yeah, so that's the normal rotation. I suggest you to do this. Don't or else, okay, if you are so expert and maybe after solving a lot of questions, you will do all these things in your brain, but still I suggest you to write it in the exam. It's for better clarity. Now I can do one thing, since I can completely say, okay, now my next target will be making this one 0, because I want to create the steps. So to make this 0, I can multiply negative 1 over here and add it. So I can say my r3 will be negative r2 plus r3. So what it will do is 1 1 1, no change in the r1, and here you will get 0 1 minus 1, no change in r2, but here 0 0 0 0. Correct?
Okay. So but you have this one minus, and you added to this
Yeah,
third.
I added the negative of this one.
Okay. That's
Because okay, my original idea was not to make all these things 0. My idea was only to make the steps. So my idea was make this one 0, this one 0, this one 0. So this is my main idea. Then I can solve the equations. But while doing,
Yeah, because over here there was still a 1. So we needed to get this to 0 as well.
okay. The last.
yeah.
This is a row. What's this called? Like the vertical
Column.
Row
column.
7.
Yeah, the column. The column should be all 0, and
No, this is
No,
not.
this is a row.
This is a row.
This
Yeah,
row, this is
a
column.
column. Okay, the row has to be all the elements has to be 0.
No, not all the elements of the row has to be
Okay.
0. As I said, my idea was to make this one 0, this one 0, this one 0. Only
Okay.
these three things 0. Why? Because from here I can directly say 2 times of z equal to 0, so I can do that. But
Okay,
My-
but first you want to have the value of z.
Yeah,
So,
yeah.
Okay. But there is also another way. If okay.
there are several.
So, but
ways,
here
but-
we have like everything 0 here.
yeah, it got 0 actually. My idea was not to make all of them 0.
Okay.
My idea was just to make these 3 elements 0.
Okay.
So here, since I get all these lines are 0, so there is a free variable, that is z is a free variable. Then my second equation will be y minus z equal to 0.
Okay.
So y equal to z. Okay, I got this one and this one from the last equation, but the first equation is x plus y plus z equal to 0, and I know that y equal to z, so x will be 2. Okay.
Okay.
And z is the free variable.
Yeah, so from here I say z is free variable. The other way to write z, as you can see, z equals to z, where z belongs to r. Also you can do like this: z equals to t and t belongs to r. Both of them are the same thing, but I prefer the first one.
The free variable means z can have every variable which
Yeah.
is in the R.
Yeah.
So but when do we actually call a free variable?
When you have all the rows equals to 0.
Okay.
Yeah.
So since it's the third, we call it z is 0. So if we have second row
Yeah,
is
yeah,
also, then
yeah.
y is if
Yeah, but subject to condition. Sometimes you will see in some questions we will change the rows,
okay.
so you have to be careful in that. You have to remember. That's why I said write
Okay.
this thing, because if you have complicated questions, you mostly there are no complicated questions.
One question
Yeah,
about
2 fingers.
linearly independent and dependent.
Yeah.
This row is linearly dependent.
Yes.
Right.
Whenever you are our last topic of today's, not last topic, something in between the topic is linear dependent and linear independent. I will say you what is the traditional method and what is the fastest method to do that.
Okay, just one question
Mhm.
which I want to know is that we're gonna have 10 till 12 classes.
Yeah, 12 classes.
12 classes. Okay. And how are we going to divide the entire syllabus in the 12 classes?
My first class it is on basics, so this one will help you to solve 2 questions from your first partial exam. Why I am focusing on partial exam, because it's, if you're able to solve the first partial exam, you have the idea to solve your second partial exam first question, and you have also some bit extra idea about the second partial second question as well. So yeah, our first 4 5 lessons will be completely on partial 1. Then we will do some advanced questions on linear maps. Then we will go for orthogonality, eigenvectors, eigenvalues, and all these things. Our last 3 lessons will be on affine transformation, and in between you have one simulation, and after the lesson you have 2 simulations, and you will get the complete schedule of the class, what are the topics I gonna cover and everything by tonight.
Okay.
Okay.
Yeah. Since this is a crash course, I will not go to the detailed theory, how it is, how to derive it. I will skip all this part. No proofs, nothing. Only I will say you the required theory, the tricks, the concepts, then question. Because here, concept is more important. Like as he said, his question was on linear dependent and linear independent. Whenever the questions usually asked in the exam, most of the people they also don't know the spam or the basis should be a linear independent terms, and
These two would be the basis.
sorry,
These two would be the basis, like
yeah.
these two equations.
Actually now I'm solving it, so after getting the solution I will get the basis, but the thing which you are saying is bit different. When you have 3 vectors, okay,
Oh yeah.
and you want to check whether they are forming a basis or not, then you have to like put it in the matrix. You have to check whether something is getting eliminated or not. If all of them is getting 0, that means this row can be written as the linear combination of these two.
Yeah.
I will say it, don't worry, we have the topic.
This will be covered in today.
Yeah.
Okay.
So coming back to our original problem, we got one line 0, one complete row was 0. So since this row was z, I say if all the elements of the row become 0, I say z as a free variable. Then I go up equation, so it's y minus z equal to 0. I got y equal to z, and x plus y plus z equal to 0. So I substitute this one over here. I got this thing. Now you have to write the solution. So the solution will be x, y, z, and there is a free variable. So the free variable is z, okay, and x is minus 2 times of g. X is minus 2 times of g, and y is 1 time of z, and z is equal to z. So
Okay.
my solution that I got is 2 1 1. I have a small question.
This is in
to
vector
you.
form.
This is also in vector form. This is that's my question. What is this?
the dot product. What was it? I don't know. It's the term of
No,
if you show a vector like
is something it starts with S. Can you remember? If I am writing something inside it, what does it mean? For example, if I'm
Solution.
writing, no, it could be a, but not. You are saying something particular, but my question is, what is this in general?
Oh,
So if I'm writing maybe 1 comma 0 or 0 comma 1 in this bracket, what does it mean?
the bracket. What does the bracket mean?
Yeah, why I'm not writing like this? Why am I using this one? What's the difference between this thing? This is called a span. Span of the vector. So if you're writing something inside it, that doesn't mean that there are only just two elements. It means that there could be something alpha time of 1 0 plus beta times of 0 1. So and alpha beta belongs to R. What is a span? So I will say that these two elements, you have a vector space, like say two vector space, right? So you have a 2D space, and using this two element, you can reach to every single element that will present in this vector space. Just give an example, which given 2D coordinate, give me a 2D coordinate, and that you want to reach by this vector space. Anything, maybe 99 100. So there is a point, if you have a point 99 100 over
you have
here,
to find the value of alpha and beta.
yeah, so it's so simple. So alpha equals to 99 and beta equals to 100.
Okay, yeah.
So that's my point. This is called as the span of the vector space. So it's not just two elements, it's the linear combinations of the elements that is present over there.
Okay.
So it not just one element, it's not just one element, it is infinitely many solutions.
Since the z is our alpha here,
Yeah,
we can have infinite values. for
exactly.
Z. Okay.
So
But this one has two elements, but it's because alpha and beta can be anything.
yeah, our linear algebra, so for the linear combination you have to have two properties. One is the addition, subtraction, and the other one is the multiplication. So using this property, you can reach to every single combination. So in short, anything inside this is the linear combination of them. Okay, now we started with an homogeneous equation, okay, and we got infinitely many solutions. Like that, I have 5 exercises, 5 examples, but I will not solve 5 of them. I will solve just one more, then rest is on you. So I am solving the number 3 exercise number 3. Again, you have 3 equation. One is x plus y plus z is equals to 3. Then you have 2x plus 2y plus 2z is equals to 6. X minus y plus z equals to 1. Find the solution. As you see, it's non-homogeneous. So if I go back to my theory, there will be 3 possibilities. Let me copy this one. I think it didn't copy. Okay, leave it. So there are three possibilities. One is no solution, one is one unique solution, and the other one will be a particular solution plus infinitely many solutions. So this could be any of this thing. Let's solve and check it out. It's 1 1 1 3. All the constant term you need to write at this side. So my idea is to make the steps, right?
Okay.
So first I will multiply -2 in R1. So my R2 will be multiplying -2 in R1 and adding them with R2, and simultaneously I can do R3 is equals to negative R1. Why I am doing this? To make this one 0, right? I am multiplying negative here and adding it. So if I do that, this thing will not change. Okay, this will be remain the same, but here you will get 0 0 0, and this is also 0.
Yes, -6.
Yeah.
Zero.
And if I do this one as well, I will get 0
-2.
-2 0,
0.
and here I multiplied
Minus
-3
2.
plus 1, so it's -2. Okay.
Mm.
Here I got, okay, there is a y term here,
You
there
can
is
switch it
no
up.
z term. I'm avoiding to do that, but you can do it. So you see there is no z term here, so g is a free variable. Okay, this belongs to R.
Z is a free variable.
Yeah, you see.
You see, this is X, Y, and Z. Right?
Yeah, if I write it more clearly, it's 1 1 1 0 -2 0 3 -2, then the last line you have 0 0 0.
Why you substituted the second row with the third?
No, actually I swapped them because just for clarity. So
Okay.
now you see you have the y term, you have x, y, and here you have the g, but the last line is getting 0.
So when you change the rows, it's that last solution. So but this becomes now here we have y as a free variable.
Actually, no. Actually, the thing is, even if you write the equation from here, you will get this one is -2y is equals to -2, right?
Okay, yeah.
Because this is equal to 0, and first equation is x plus y plus z equals to 3, right?
Okay.
Then you see there is no g here, so z is a free variable.
Okay.
So it's not about the order, it's about like the position of the elements.
Right.
So even if I write the equation from here as well, I will get the similar result.
So here we have y equal to 1. So this is only
Yes,
1.
yes. So okay, z equals to z, so I can put y equals to 1 here. I will get x equals to
Okay, now I
2
get it,
minus
because
z.
here we have 0 here for
Yeah.
the value of z, then we call it
No. Where? Over here.
the third row.
No. Z is coming from here. Second row.
Z is coming from.
Since, okay, forget about the position of the rows, forget about that. Start writing the equation. what you will write? This one as x
Y.
plus y plus z equals to 3,
3, yeah.
right? You cannot write anything here, leave it. Then you go to this line, you will write 2 times of y equals to minus 2,
Okay.
right?
Right.
Then
yeah.
now you don't have anything, so z is
yeah, Z
remains,
is
so z is
like
a
we
free
don't have
variable.
an equation for Z, so we call it
Yeah.
different. Now I understand. Yeah. But it has nothing to do with the order of the
Yeah,
rows.
yeah, it's nothing to do with the order.
Okay.
So yeah, now we got these 3 cases. So if I write the solution as x, y and z, there is a particular solution. So the particular solution is 2 1 0 plus, is a free variable as g, and this is minus 1 0 1. Let me write it more clearly. So the solution which I got is 2 1 0 plus minus 1 0 1, the z multiplied, so I can write it like this. This is the solution. Do you understand, like, from how I go from here to here?
Oh.
You can check it out. There is a constant here. No free variable is multiplied. There is a constant here. So the solution, if you write these 3 equations in this form, first you write the constants. X has 2. Okay. Can you go from here to here? Is it the same thing or not? Can you see it?
If we have put this 1 2 1 0 here, it will satisfy all equations.
These are just the constants.
This I'm not doing anything. This is written over here. I'm just rewriting in this form.
So how
Can
do
you
actually?
Yeah, so that's my question. Can you imagine that both these 2 things are same? No. Okay, let's see
No.
right now. If I write the equation of x is
2 plus
2 plus, but there is a negative 1 over here. Negative,
2 minus.
right? Is it matching with this one?
Yeah.
Okay, write the equation of y as well. So y equals to 1 plus 0 times of z.
It's y
the
is
same?
the constant. Yeah.
Write the equation for z is 0 times 1 times of z.
Yeah, it's correct.
So
Yes, the combination between this. So yeah, so this is another form of
Yeah.
the solution.
yeah.
Okay.
So and now as you know, there is a free variable here, so I can write it as a span of the vector. So I just rewrite this one and this.
Okay.
So we got this one, our particular solution, and this one as general solution. So also, most popularly the same, when you solve only, when you just if you want to solve only the homogeneous part, if you make this one 0, this one 0, this one 0, you will see you will only get this part. So this is the homogeneous part of the solution. It's the homogeneous part, and this is the full solution. This is the full solution. It's a combination of particular solution plus general solution.
So we do not have to make 0 to only have the homogeneous. So the steps that we do works for, since we're
Yeah, even
finding
if you, as I say, if you take all this thing 0 0 0, this 3 will be 0, right?
Okay, so
The
but how
constant
can we
term.
do that? We can just multiply -2 to here to make this one 0. So
No, he's saying consider.
I said consider.
okay, if we do, yeah.
If you do
But I
that, this
don't think
thing.
it's possible.
No, why it's not possible? It's
If you
possible.
consider it's possible, it's possible.
If imagine there is 0 over here, there is 0 over here, there is 0 over
Okay,
here.
yeah, but
So
this is homogeneous.
yeah, this is homogeneous. So if
Okay.
you solve only the homogeneous part of the equation, so this thing will be 0, so there will be no change over here. No
Yeah.
matter you multiply 3 over here, you add it over here, it's the same, doesn't matter. So at the end you will have, instead of this thing, you will have 0 0 0, right?
Okay, yeah.
So you will have minus 2y equal to 0,
Okay, yeah.
y equal to 0.
Yeah.
You will have z equals to z,
C is a free variable.
and you will have x plus 0 plus z equal to 0.
Okay.
I put y equal to 0 0, so you got x equals to minus z.
Okay.
So if you write
Only
it,
it feels, since z is a free variable, we can write
yeah, so you will get
minus
minus
1,
1.
0 and 1.
Exactly.
Okay.
Okay,
Yeah, infinitely.
yeah. So let's go to our notes. Who is responsible for infinite many solutions?
0.
Hmm?
Who?
Yeah, who is responsible? Like which variable is responsible
0.
for? Free variables, right?
Yeah.
Yeah, free. So free variables are responsible for infinitely many solutions. Yeah, so if you have the free variables, you will be pretty sure that you will have infinitely many solution. One more case, you will, when you will solve this 5 exercises, exercise 1 1 2 3 4 and 5, you will cover all the possible cases that I have defined here, like 2 cases of here and 3 cases of the non-homogeneous part. So it's your task to do it, but I'm just giving a hint. For example, if you got a case like this, there is something over here, some elements over here, you got 0 0 0, and there is something over here, something, and there is 3 over here. What will happen?
So that these 2 rows can be anything?
Yeah, can be anything, it doesn't matter. My focus is on this one.
So if we make this one 0, then we
No
have...
solution.
You cannot make it 0.
No solution.
It's no solutions.
Because 0 can't be equal to 3. Right?
Okay.
So if solving any linear equation, you arise with these cases.
Okay, in this case we do not have any...
No solution. And yeah, so this 5 exercises will cover all the 5 cases. I will say it to you and you have to solve it. Then going to the next topic.
So it's definitely non-homogeneous because we have 3 possibilities for non-homogeneous. One
Yes.
of them is that does not have an...
It's a non-homogeneous, yeah.
Okay.
If you have, you see there is a constant term which is not zero. It's obviously non-homogeneous.
And it doesn't matter that anything else is on this deck for
Yeah.
2 rows. Okay.
Yeah, as I have some conceptual question. I think you know it. What is a free variable? You know what is a free variable. What is this spam? You already know it. And yeah, the question was linear independent and linear dependent.
the definition of free variable, just to be clear, is that it is not dependent on other variables. It is independent.
It has no particular value. The value of free variables, it could be anything on real number. It could be any real number.
Okay, as we indicated for Z set, it
So
belongs to our
yes,
any number.
yes. Yeah. One more popular topic: linear, independent, and linear dependent. What do you mean by this? Just from the word, like from the terminology. I'm not going to how you do it, but what is the definition of linear independent?
Okay.
Can you define it?
One thing that I know is we cannot write a linear combination of if it is linear independent, there is no linear combination that gives that equation.
Exactly, that's the definition. And if you go to linear dependent, it can be written as a linear combination of the other vectors. For example, if you have 1, 0, 0, 1, 2, 3, are these linear dependent? Sorry, are these linear independent?
We can have a value for alpha and beta just to, like this third vector is linearly.
If they don't have a scalar between them, they're linearly independent.
Yeah, if you don't get values for alpha and beta, they are linear independent. If you get some value for alpha and beta, they are linear dependent.
So alpha can be 2 and beta can be 3.
Yeah, alpha equals to 2 and beta equals to 3. You got it.
And how should we calculate alpha and beta? Because this is very simple.
Yeah,
But, we have,
I will tell you some method that you will never calculate.
If we have a vector in R3 or R4, this is not.
Yeah, you will never do in this method. I will tell you to which method you should prefer. Okay. For example, if you have 4 vectors like x1, x2, x3, x4, and also let me write it like this: x1, y1, z1, t1. Similarly, you have x4, y4, z4, and t4. Okay, so you have 4 vectors like 1, 2, 3, and this is the 4th one. So if you want to check whether they are linear independent or not, so the best method for do this thing is not multiplying alpha, beta, gamma, delta, then equating 0, then finding the value of alpha, beta, gamma, delta is more complicated. Just put them in the rho epsilon form. Okay, write x1, y1, z1, t1, x2, y2, z2, t2, x3, y3, z3, t3, x4, y4, z4, t4. You try to make the steps. Okay, first you put it in the rho epsilon form, then you try to make this one 0, this 2 0, this 3 0. If after doing the steps, if you get some line that is becoming 0, for example, by doing this, if you get this line, this all the 4 rows are equal to 0 0 0 0, you will say that these 4 vectors are not linear independent, because this vector, the vector 3, can be written as the linear combination of vector 1, vector 2, and vector 4.
So the whole system is not linear independent.
Yeah, and if you want, yeah.
I have to take this.
Okay.
Sorry.
Okay, it's fine. One thing, we can, after doing this, we can say that all these 4 vectors are linearly independent, or only vector 3s?
Okay, if you get this one as 0 0 0 0 0, you will say that okay, this one, and this one are linear independent. But if you take all those 4 vectors, they are not linear independent, they are linear dependent, because if one of them is linear dependent, and if you are considering for all the 4,
Okay, so these 3 vectors are independent.
yeah,
But the whole,
it
whole
could be,
four-
it could be, or it couldn't be. But if you completely make the steps, okay, for example, if you get like this one is non-zero, then you got this one as 0, or all these 4 are 0, and this one 0 0 0, and this is non-zero. So
we
then
have
you
to
can
reach that way. So if we do not have all these values 0, we cannot decide.
Yeah. You will see a lot of examples then.
Okay.
Let me pause it. So I have taken a question from the partial exam of 2021. No, 2022. Sorry, 2022. The exercise was you will get acquainted to these terms if you are not acquainted right now. I will solving the questions. You have the equation of u as x1 3x2 minus x3 is equals to 0. Then you have 2 times of x2 minus 2 times of x3 minus x4 is equals to 0. Then you have w. It is okay. Now you see these are equations. The question could be given in equation, or it could be given as a general point. So for w, it has been given a general point, it's like coordinates. So it's a plus 2b minus b minus 2a plus c, and a plus 2b plus 2c. So from now there will be no boring theories. You have just exercises, and from exercises we will know the theory. Question 1, find u and w. Question 2, find u intersection w. Question 3, u sum w. Question 4,
Expected. आप लोग continue.
you can talk here.
Yeah.
You can talk
No,
here, it's
no,
better.
I don't wanna talk.
Okay.
Please continue.
Okay.
And if I have to leave right now, could you just send me the PDF?
Okay.
Okay.
So you have one question number 4. You have L, that is the dimension of the L is less than 4. I will tell you what is this.
The
Line.
term that
Yeah. And U, I will tell you while solving the question, don't worry.
this, I know this term. This means that does not have an intersection between these two, the plus and
Independent sum, we say that. It's
Okay.
direct sum.
direct sum.
Yeah. Then you have T less than R4 such that we will get to each and every question, don't worry about that. And equation of W. So let's first decode the question. First let's decode the big question. We have one vector space where the systems of equation is given to you. So here it's the systems of equation given to you. Then you have a general point. Here is not equation, it's a general point of any vector space. So first question is find the solution of u, find the basis of u, and find the basis of W.
Means find A and B here.
No, basis, it could be like find the solution, like solve this equation.
Okay.
Or here you will find, I will tell you how to find the basis of this one.
Okay.
Then you find the intersection U intersection W. Then you find this is the common solution in between them. Common solution in both. And this one is sum of the solutions. I will tell you how to do it. And this one is you have to move. L is a vector. What does this question means? L is a vector whose dimension could be 0, 1, 2, 3 or 4. Okay, it's a vector whose dimension could be like 0, 1, 2, 3, 4. Do you know what is the dimension of a vector space?
Yeah, it means
The number of elements.
Number of elements.
Yeah, the number of vectors are there. So the dimension could be like this thing, but when you add, when you take the sum of U and L, that dimension should be equals to 4. This dimension should equal to be 4, and the addition should be linear independent.
Oh, which one is linear? L is
The addition of,
okay.
after adding it, it should be linear independent.
Okay.
So let's solve it, then you will have a clear idea. Solution. So first let's solve for U. This one. Sorry.
Yeah, hopefully I'm calling. I'm calling to receive.
No, it's okay, don't worry. You can use there's a kitchen, so you can go there and you can talk.
Okay.
Okay, as I was just decoding the question for him.
That's fine.
Okay, now we will now all the remaining time of the lesson we will solve this question perfectly, and we will gain all the concept, so that after this question, like after solving this question, you will be able to solve all the types of question related to this things. So there are 6 bits in this question. Let's start with the first bit, the first half of the first bit. So you have the equations for U, and your idea is to find U. How to do it? You do the epsilon form. You write in the epsilon form as 1, 3, minus 1. Okay, you see this is x1. In this lines you have 4 variables. It is x1, x2, x3, x4. Okay,
x4 is 0.
Yeah, for this line, yes, x4 is 0, and here 0, 2, minus 2, minus 1. Okay,
Okay.
so it's already in row epsilon form.
You don't have to write the zeros like here.
It's okay, but since it's a homogeneous equation, you can skip it as well, doesn't matter. Okay, so it's already in row epsilon form.
Yeah, it is.
Yeah, so you don't need to do the steps. The step is already there for you. Okay, so if I write, okay, and that means there are 2 other rows which are 0, because it has 4 variables, right? x1, x2, x3, x4. So I can say that x4 is equals to x4 belongs to R, x3 is equals to x3 belongs to R, then x2, here you have 2 times of x2, right? Here it is 2 times of x2. You can keep everything here, like x2 this side and the rest of that side. So it will be 2 times of x3 and plus x4, right?
Right.
So x2 will be x3 plus half of x4,
Okay.
correct?
Yeah.
So of this one, and we have the first equation as x1 is equals to negative 3 times of x2, x4, sorry, x3, is it? Yeah, is it negative? So here it was negative, I took it to that side. So then you can substitute the value of x2 over here. Okay, so my x1 is equals to negative 3 x3 plus x3,
You actually are
sorry,
the, you're adding.
yeah, I'm putting this value over here,
Okay, the x2. You're putting x2 in this one.
x2 in the x1, this equation.
Okay.
So just to get it in simpler form, so I got x1 is equals to negative 2x3 negative 3 by 2x4. Okay,
Okay.
correct. Then I can write the solution x1, x2, x3, x4. There are two free variables, right? There are two free variables and there are no constant term. It's a homogeneous equation. So first free variable is
Just to
x3.
be clear, you want a combination between x3 and x4 since
Yes.
they are free variables.
Yeah.
Okay.
So I can write here minus 2. Okay. Then for x2 you have here 1. X3 is equals to 1 times of x3 and this is 0. And this one it will be minus 3 by 2 x4, minus 3 by 2 x4, and here my 1 by 2 x4, and this is 0 0 1. Any doubt here?
Okay,
How I
can
wrote
you
this?
yes, exactly say how do you write the numbers of
Okay,
elements?
here is x1 and see the equation of x1. This negative 2 of x3,
Okay,
negative 3 by 2 of x4,
x4, yeah, correct.
and if you observe this one, similarly you can do that.
x2.
Okay,
One and
one and half, one and half,
one and a half. Okay.
and see the equation of x3. It's just x3, no x4.
No, x4.
So x3 is 1 times
One.
of x3, 0 x4,
Okay.
and for x4 is 0 times of x3.
x4. Yeah, that's right.
One more thing, if I want to like have good looking solutions, so I can multiply 2 all over them is okay. So if I multiply 2 here, 2 here, I can just make it 2 here. That's okay.
You can multiply
Yes,
an
yes.
exact number to any
Yeah,
solution.
yeah, doesn't matter because x4 could be anything. So
Okay.
we don't have just one. Okay, you cannot do that with particular solution. Remember, you cannot do that with particular solution. This is the spam of the vector space, so you can do it. Here you can write u as minus 2 1 1 0 minus 3 1 0 2. This is my u.
If someone forgets to multiply it, this is also correct, right? Or it's better to write it in the most simple.
No, always, since I have asked what is u. Okay.
Yeah.
So the question means what is the basis, find the basis of
Find
u
the basis of u.
and dimension of u. How many elements are there?
Basis should be like what do you call it? Integers, like
Linear independent.
linear.
And you know the best, there is one more also fastest way to check linear independent. You can check it in that. But here why I didn't check the linear independent or dependent, because you see the zeros are in different position. can see this is the 0 is here in the fourth element, this is the third element. So do whatever you want, they cannot be the same. That's the tricks to
X3 and X4 cannot be the same.
yeah. So I didn't check for linear dependent because whenever you are writing something inside this bracket, you should check for whether they are linear independent or not. If they are linear independent, then you can write it. So I didn't check it because the
The
zero,
span of a vector should be independent, right?
yeah, basis of any vectors should be a linear
Basis
independent.
should be independent.
So, and dimension is the number of elements in the basis, so it's 2.
Dimension.
Yeah, 1.
Yeah, X3 and X4, there are 2.
Let's do for W. We just solve this one, and now let's do this one. For W, we don't have the equation, we have a general point. So how to do it with general point, let me show to you. Okay. Now you have okay. Now let's just now take all the A from each side. So if you take the common A over here, I can also write this one, W equals to, if I take A, you have, what is the coefficient of A? 1. Here 0, here it's -2, here it's 1, right?
Yeah.
And second, I am taking the B, 2 minus 1 0 2, okay. And for C, I am taking 0 0 1 2. You are almost done for W, but before writing or declaring them as basis of W, check whether they are linear independent or not. So if you do that, 1 0 minus 2 1, 2 minus 1 0 2, 0 0 1 2. So as I say, try to make this one 0. So if you are getting a step, if you are getting no such rows, all the element will be 0, so they are linear independent. You can check it out by yourself, but since I am seeing the zeros are in different position, I can see this cannot be a linear combination of this one, so I'm doing it in fastest way. But you always prefer by doing the steps, try to make this one 0, and
then multiplying -12 first row to the second.
Yeah, you can do it. Let me do it as well. So it's 1 0 -2 1, and if you multiply -2 here is 0
minus 1
-2, if you multiply is 4, right?
4, yeah.
And if you multiply -2 is with 0, and here you get 0 0 1 2. So I already got a step, okay. And no matter whatever you do, you cannot make anything else. You cannot make any row 0, so they are linear independent. Since they are linear independent, I can write W is equals to 1 0 2 okay, then it's minus 2 minus 1 0 2. Okay, so this is the this is the basis of W. So
This is the one that you write it in.
for you,
So we just check the linear independent here.
yeah, I wrote here, but before writing in this, I have to check whether they are linear independent or
So
not.
if we have all this terms 0, then we are sure that.
Yeah,
it's,
then you have to eliminate that one. So
Oh.
if this would have been become 0, so I would have not written this one. Right? Now I can say my dimension of W is
3.
3. The first bit is solved successfully. Okay, and coming to the next bit,
Hello.
U intersection W.
Okay. Please send me the.
Okay.
Okay, fine.
So U intersection W. Here you have to find the common solution between U and W. There are several ways to do it. Since okay, so now you imagine you have U, you have W, and you want to find the common solution, the intersection solution. What you can do first, if you have equation over here and you have equation over here, imagine, now just imagination, you have equation over here and you have equation over here. So what you can do, you can solve all the equation at the same time, and the solution which you will get is the intersection.
Okay.
So for example, so if you have for U intersection W, if you have, imagine if you have equations of U and if you have equation of W, what you can do, you can solve the equation of U and equation of W at the same time, like you will put it in the row epsilon form.
Okay.
You will do this, then whatever the solution you will get.
Doesn't matter how many equations.
Yeah, it doesn't matter.
So for this one, we have like 2 equations for U and 2 equations for.
No, we don't have equation for W. That's the thing.
Okay, yeah, we are imagining that.
Yeah, we are imagining. So whatever the solution you will get is U intersection W. But now you see, now you have a general point in this our question. In our question, you have an equation and a generic point, right? Am I correct?
Yeah, that's correct.
So here the idea could be, take this generic point, take the generic point and substitute in the equation. So you will take this generic point and you will substitute in the equation of W. Then you will get some values for A, B, C, D or something, the variables of generic point. So that is the generic point of U intersection W. Simple idea. We had a generic point, we had equations. If we had equation, so we can solve it together, but since we had a generic point and you had equation and you want to solve it faster, so you just take the generic point, put it in the equation,
Okay.
then you will get some relation between a and b, so that put it in the original, substitute in the original generic point, you will get the generic point of u intersection w. Let's do it so that you will have a clear idea. So u intersection w will be, this is my x1, x2, x3, x4.
Okay.
I substituted them in the equation of u, so it's a plus 2b plus 3 times of minus b minus, then you had, okay, you have to multiply this one all together, then you had a minus 1 multiplied with, this is x3, so I can write x3 over here,
2a minus c
2a plus c,
plus c.
yeah, I will do it later, equal to 0, and here I can do,
The dimension of w is 3 and that one is 4.
yeah, but now I'm not doing anything.
Okay.
Right. I'm just taking this general point and putting it over here to
Okay.
find the u intersection w. So this one I can write 2 times of negative b, 2 times of negative b, okay,
Okay, the second
yeah,
equation.
the second equation, 2 times of negative b minus 2 times of negative 2a plus c, then negative 1, and this term is here, a plus 2b plus 2c is equal to 0. Okay,
The last one is minus 1
minus 1, and
in
this
here.
is, yeah,
Okay,
correct.
correct.
So let's simplify this one. Here you get a, okay, then this is plus 2b minus 3b plus 2a minus c is equals to 0.
Okay.
Okay, then here you have minus 2b plus 4a minus 2c minus a minus 2b minus 2c is equal to 0, right?
Okay. Yeah.
Then identify all the a terms here, this is a, so I can write 3a, okay, minus b minus c is equal to 0,
Okay.
and here you have a here, this two is like you have 3a, right?
Okay. Right.
3a, and you have minus 2b minus 2b, so it's minus 4b, okay.
Okay.
Then for the c you have this 2, so it's minus 4c is equal to 0,
Yeah. Correct.
correct. So I want to get some relation, so I can I can write this way, c 3a equal to b plus c,
Okay.
and here 3a equals to 4b plus 4c,
Yeah. Correct.
so I can equate them, b plus c equals to 4 times of, no, there is something mistake, just a minute, I'm doing some mistakes. Let me,
To check u intersection w, the dimension is always less than the dimension of the greater. There is a rule that.
yeah.
So we will
So
discuss.
for example, yeah, we will when you will solve like 2-3 questions of this one, you will, I don't need to repeat those things. Obviously I will repeat like those forms, but you will automatically understand it, you can see it.
It's called
Like for example, if you have the u intersection w, the dimension of this thing, it now you have imagine there is something, this is a vector space and this is a vector space. So if I want to take the common thing, maximum it could be this one, the maximum could be the common part, the maximum will be this one, right?
yeah.
So the dimension of this thing will be
3x
less or equal to
to
our dimension of u was 2,
dimension of
U
u was
was
4, right?
w was 3,
W was 3 and u was 2. So
which is
how
less.
how would you use 2?
Sorry,
So how do you consider your...
two elements 1 and 2.
Okay, that's...
So
So it's, the intersection should be 2 less or equal to 2.
less or equal to 2. Exactly. Okay, you addressed your own question. Okay, so now let's come to u sum of w. So you will sum all the solutions of u and w. This is the most easy one. You have already solved u, you have already solved w. The best way to put everything in a rho epsilon form, put the basis of u, put the basis of w. Just a minute, let me just go. Yeah, I'm back. So put everything in the rho epsilon form. Then yeah, we had u, we had w. So the dimension of the vectors of u that we get in the question, it was like 2 -1 -1 0, 3 -1 0 -2, and for w we got 1 0 minus.
First you write u, then w.
Doesn't matter.
Okay.
0 -1 4 0 0 0 1 2. So you can check it out. I just wrote all these things.
Okay.
Yeah. Now you see, you have x1, x2, x3, x4, and you have 5 rows. Obviously it's not possible, there might be something is linear combination of other one. So your idea is to make the steps. Okay, so you will try to make the steps and you will see there will be something will be eliminated.
Yeah, one row is all 0.
Yeah.
Okay.
So for me, the best approach, I will take this one to the up, I will take this one to the up. You see what will happen. I will take this one to the second row. Okay. So you see what I will do for easy thing. I will do like, okay, 1 0 -2 1, 0 minus 1 4 0 0 0 1 2. Then I wrote all this. So I just like swapped u w over there and u over here. I don't made any other changes. That's it. So you will see, yeah.
That's the same as that one. The W is
Yeah.
first and U.
Now I will do one thing. For me, I will multiply -2. Okay, my R4 will be -2 R1 plus R4. I want to make this one 0.
Okay.
If I multiply -2 here and add it over here, I multiplied -2 here.
-2 and add it here. Okay.
Yeah, and I will multiply -3 in R1. Then I will add it to R5. I will multiply -3 and add it to here.
Okay.
Okay.
Yeah.
So what will happen? I'm not writing these things. I'm just writing this two part. Okay.
Okay.
So this one will be 0. This one will be 0.
0. Yeah.
And this one will be -1.
-1.
And this one will be 4.
Minus
-1
1,
3. And this one will be -2 0. -2. And for this one you will get 0. Okay.
-3 or 1. Yeah. 0.
And this one -1.
Okay. And the 6.
And this one will be how much? It's -3 is multiplied 6. And this one will be
-5.
-3 and -5. So now we got this thing. So let me,
We have 2 0 here. That's good.
yeah, then we can do one thing. I can take the negative of this one
Okay.
and add it over here and here.
Negative of this one. Yeah. Then we will get another 0 here.
Yeah. So
Write it directly. I will.
yeah. So this is 0 and this is -4. This one -5 and this
0.
is 0. And here if I do it,
This is
this
0.
is 0 and
0.
0. And if I multiplying -4
Negative.
and this one -2, right?
-5 is here.
Sorry.
We are doing we've done this step, then we are changing.
Yeah, exactly. Am I correct or I made
So we
some
have,
mistakes? No,
yes,
also
the
here
mistake,
it's
it's a
also
6
mistake.
here.
Yeah. So it's a 6 here, and what we did here, we just did 2.
-2.
-2 or
No,
plus
2. We have -4 plus 6.
Yeah.
Okay.
So we got this one.
Okay, that's better. We have 2 zeros here.
And if we compare with the original case, so just a minute, I'm not doing any mistakes. That's okay, let's proceed.
Then in the next step, we have -2 here, so we can add it to this one.
No, if you add something, this
Okay,
one,
then we'll go Okay, no.
Yeah. So don't ever think to do that.
Okay.
So now let's not touch this one, because it's, you see, if I put this one over here, it will be always in this form. Okay, now just let's do something with this thing. If I multiply 2 over here in this one, -2, and add it over here, multiplying -2 and add it over here. And also I'm okay, let's also change this one. No, but
negative add it into R5.
Yeah, if I multiply 5 and add it over here.
Okay, we have another 0 here.
So if we multiply 5 here and add it over here, it's 0, 0, 0. I multiplied 5 and add it over here. So
5.
yeah,
Okay.
and this is 10.
Okay. 10. Okay, 5 is 10.
Yeah. So this one is, and here I am multiplying negative 2 and adding it over here. So 0, 0, 0. Negative 2, if I multiply, it's negative 4. Negative 4, and here you have negative 5. So it's negative 9. Right?
It's like a bit confusing. So you said that we do not touch this one. We keep it.
But still, then I plan to change it.
Okay. So how do we get?
I multiplied for the first thing, the first row, I multiplied this here as 5 and I add it over here. Okay.
5 and add it over here.
Then for this case, I multiplied
You want to have this minus 5
to be
0.
0. Yeah.
Okay, that's clear. Okay. So then we have this 3 0 and that one
Yeah.
10.
So
And
now,
for that one, how do we get minus 9?
okay, if you multiply minus 2 in this line and you add it over here, so this is 0, 0. This one will be 0 because I am multiplying negative 2 and adding over here.
Okay, this is 0.
And if you multiply negative,
minus 4 plus minus 5 is minus 9.
okay,
Okay.
and here you can eliminate one of them because because if you multiply plus 9 over 10 in this row,
Okay,
and you add it over here, so it will be
0 all 0.
So
Okay,
you can eliminate this one. Now you just remaining with 1, 2, 3 and this one. So I can remove these two lines and I can just write 0, 0, 0, 10. So you are in a epsilon form, right?
Yeah, right.
So your u plus w is equals to 1, 2, 3, 4.
These 4 rows are the solution.
Yeah, solution of u plus w.
Okay. And
Easy?
Not really easy because it's.
But the concept is easy.
Yeah, the concept is easy. The dimension of u plus w is 4, right?
Yeah, it's 4. So, okay. The dimension of u plus w is equals to 4. Let's decode it. What will the dimension of u plus w? Always you see, first of all, what is the dimension of u?
It's
2. The dimension of w was
3.
3. So it should be always less than equals to 2 plus 3, that is 5. But you have one more condition. All of these are in R4, right? All of these are in R4. So what is the maximum dimension for R4? This dimension is 4, right?
Okay.
So it cannot go above 4. It should be always less than equals to 4 because of this boundary, because of this condition. Because you have only 4 variables, x1, x2, x3, x4. So it's never ever possible that you are dealing with this 4 and you will get a dimension 5.
Yeah.
It's impossible. So this u plus w will be less than equals to 4 always.
And also greater than 3. It cannot be less than 3.
Yes. Also, okay, no. It should be greater than 2.
Greater than 2.
It should be greater than...
So it can be 2?
No.
In case?
No. It should be greater than equals to 3.
Okay.
That's more correct.
Okay, yeah.
You got it?
Yeah. Okay, 3 or 4. It is better 3 or 4.
Yeah. So we solved this one, and this one.
This one, okay.
Now we'll solve this one. How was this 3 bits? I think it was. Did you
The
understand the
first one,
concept?
yeah, I did understand.
The main idea is to understand the concept here as well.
Yeah, the steps are
Yeah.
clear and
So you have to L is a vector, okay, whose dimension is given is less than equals to 4. So whose dimension is less or equal to 4. That means it could be 0, 1, 2, 3 or 4. But when you do the direct sum, L plus U must be equals to 4. So this is the symbol for direct sum. Okay, what is a direct sum? Is U after adding L with the solution of U, it will be linear independent. You will see how. There are many ways to solve this question in the dimensions of before. There are many ways to solve this question, but the most easiest way. What is the dimension of U?
it's 2.
So the dimension of U is equals to 2, and you have to do the direct sum. So what, and the result should be, this is L. I don't know the dimension of L. Okay, direct sum dimension of U equals to 4. So dimension of L, direct sum 2 is equals to 4. Dimension of L equals to 4 minus 2, that is 2. It should be 2. Let's see how.
It's a direct sum. It's not different with.
Like direct sum is like when you add the L with the solution of U, it will be linear independent. Let's see how.
Okay.
What is the meaning of this? My idea to solve this kind of questions is like just do it as fast as possible, because these are super easy questions. Let's just copy the this thing, let's copy it. Okay, so this is my U, and I need to find L. Okay, I don't know that, but the dimension is 2. You will see how. So write all of them in the epsilon form. -2, 1, 1, 0, -3, 1, 0, 2, and I don't know about these things. I don't know it.
Okay.
So let's make this one 0. Okay, let's make this one as a step.
Okay.
So if I need to do, if I divide -2, okay, 3 by negative, okay, R1 plus R2, what will happen if I do this?
This will be 0 minus 3.
Yeah, so just tell me what is the solution. -2, 1, 0. This is 0.
3, 2 over 2. 0. This is 1.
Okay, so
Multiplied by -3 over 2.
3 over 2 plus 1. because I am
Okay.
multiplying negative 3 over 2
You are
here
adding
and
it to
adding
the
it.
second row.
Yeah. So R2 is equals to
This
negative
is minus half.
minus half, and this one will be 0. No, this one will be minus 3 by 2, and this one will be 2, right?
Yeah.
Then I don't know about these lines. So now you know the dimension of L should be 2. Now you put some values so that this will be linear independent. So if I take some values like, okay, 0 0, some alpha beta, maybe
Okay.
99 1 2 2 3, I don't care, and here I put 3 zeros, and I put some value like maybe,
So for big numbers.
yeah, it doesn't matter.
Okay.
I take 1,
Okay.
yeah, 3 something. Now you can see, say, steps. Okay, all of them are linear independent,
Okay. Yeah.
right?
They are.
So what I did, this is the u, this was my u, okay, and I found out L. I find out L, and whenever you will do the direct sum of u and L, you see there are 4 vectors, so the dimension is 4, and you got L so far. So your L is, please note the answer could be vary, but this is correct.
This is just one answer of many
Yeah.
possible. Okay, yeah, the dimension is 2 and it's
Yeah.
linear independent.
Yeah.
It has both conditions. So this question is easy actually.
Yeah. Now let's do the next question. Yes. Okay, let's take a break, then do the next questions. Okay, I forgot to start the video. So now we have to find T, whose dimension can be 0 1 2 3 4, and it should be direct sum with U, and you should be direct sum with W. So I wrote the basis of U and W in the epsilon form. Now we just need to find out the T. Okay, so for T, we what will the dimension of T first? What will be the dimension of T? Because it should satisfy two conditions, right? So T plus W. What is the dimension of W?
3.
3, and we don't know the dimension of this one. But in the question it is nothing given. It should be 4 or it should be 5 or something like that. It nothing is given, but you know we are in R4, right?
Okay.
So the maximum dimension should be less than equals to 4, right? We are in R4, so the maximum possible dimension will be R4, so will be 4. So since the maximum dimension should be 4, the dimension of T should be 0 or 1. If it is 0, T doesn't exist. If it is 1, yes.
Yeah.
So that's the case. And if I take yeah, so this one is already in step. Okay, so I just need to identify one. I can put one element like 99, and I can put this one as 99. So even this doesn't make a step, but it is linear independent, right? This one is also linear independent.
Yeah.
This is also linear independent. So my T is 0 0 0 99. Okay,
Dimension is 1.
and the dimension is 1. Dimension of T is 1.
Okay,
Easy?
yeah, it's easy, but it doesn't depend on the value of you just want this to be linearly independent. The
yeah.
value is not.
Yeah. And for the last question, we will address it in the next class. Equation of W.
Equation of.
Equation of W. You had the general point.
Okay.
Now you have to find the equation of W.
Okay.
First, I will suggest you think yourself. Think, even it will take like 1 hour, 2 hour, but think. When you think, you will use all the concepts. When you understand, okay, this has a relation, this concept has a relation with the other concept, so you will try to understand.
I should use the answers of the previous parts, I guess. Like,
No.
no, so it has no, like, so I have the general for
General.
solution of
Yeah,
W. So
you have the now you have the solution of W. You have the solution of W, but
the
you
equation.
don't have an equation. So you try to address this problem.
Okay.
If you don't do it, we will do in just 5 minutes. No
Okay,
stress.
I will try to do it.
Yeah. So that's the end of the first lesson. Here you understood what is vector space, how we are able to solve the direct sum, intersection, and all those concepts. So we cover most of the part, but as we move to the next classes, the number of problems I will do a bit more fast, and I will consider at least to do like 2 questions in one session. So those questions would cover a lot of problems. And since we are doing it first time today, it took a bit more time because I was also covering concepts with the question.
Okay.
It's more important to do to solve 1 or 2 questions but understand the concept perfectly rather than
Okay.
solving 10 questions without understanding the
These
concept.
types of questions are really useful. If you provide me with 1 or 2 more of these types, I can.
I will give it to you.
practice. Okay.
Yeah.
And one more thing. What's this term called? Like the question for L and it is less or greater. How should I read that one?
I have written, I guess, here.
Yeah, I forgot. This is called.
So L is a vector whose dimension is less than or equals to 4.
Okay.
The dimension could be 0, 1, 2, 3,
Okay,
4.
it means the dimension is
Yeah.
less than or 4,
Yeah.
which is the case here.
Yeah, I have written. If you go through each and everything, you'll understand.
Okay, yeah.
That's it. Let me turn off the video.